Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are going on well. I am starting a new chapter which is surface areas and volumes, where I will cover cuboid, cube, right circular cone and right circular cylinder. In this part 1 video, I will be discussing about the key concepts and formula of the surface area, perimeters and other things of cuboid and cube. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma, where I primarily discuss about key concepts and formulas for problem solving. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so first is cuboid. So these are all solids: cuboid, cube, right circular cone and right circular cylinders. These are all solids. We will discuss about how to find the surface area, perimeter and volume of all these solids. So what is a cuboid? A cuboid is a solid, as you can see, which is made up of six rectangular faces, and a cuboid is geometrically, a cuboid is defined by 3 dimensions, which is length, breadth and length, breadth and height. Small l is used to denote the length, small b is used to denote the breadth, and small h is used to denote the height. So in this figure, it is a cuboid. You can see that the sides which are denoting the lengths are CD, GE, BH and AF. Similarly, the sides which are denoting the breadth or the width are CG, DE, AB and HF, and the heights are the sides representing the height of this cuboid is BC, AG, HD and FE. Okay, now there are 8 vertices in a cuboid, as you can see: A, B, C, D, E, F, G, H. There are 8 vertices. Now what are faces? There are 6 faces in a cuboid. The faces are, as you can see, so there are 6 rectangular faces. The 6 rectangular faces, the faces are, as you can see, the top face is AB, ABHF, which is the top face, and the bottom face is CDEG, and all the other remaining faces are known as the lateral faces, which are BCDH, HDEF and ABCG and AGEF. These are lateral faces. Okay, now there are 12 edges. A side, 12 edges. An edge is a side or a line where 2 faces meet. A common side of 2 faces is a side or edge of a cuboid. So there are 12 edges, as you can see. The edges of the top face are AB, BH, HF and AF. I have underlined all the distinct edges. So there are 12 edges. Now these are all descriptive concepts. I mean, I don't think you will have any problem based on this geometrical concepts, but it is important that you understand. Now, so there are 6 faces in a cuboid. Any face can be the base. You can consider any face as the base, and all other 4 faces meeting the base will be the corresponding lateral faces. So if you consider, let's say, the face ABCG, this is the face ABCG. Now what are the faces that are meeting? What are the faces meeting this face? That is adjacent face. It is BCDH, AGFE and BHAF, the top and bottom faces, and also the lateral faces BCDH and AGFE. So if you consider any base, any face that can be considered as base, then its corresponding lateral faces will be the four faces which are meeting the base. I mean meeting along the sides or edges. Okay. Now let's discuss about the surface area. The lateral surface area. Surface area, or it is also sometimes called total surface area. It is denoted by TSA. Lateral surface area is denoted by LSA. Perimeter is P, diagonal and volume. Now, what is the total surface area or surface area of a cuboid? It is the area of all the six faces. A cuboid has six faces. It is the area of all six faces, and its formula is 2 into LB plus LH plus BH. This is the formula, where LBH are length, breadth and height of the cuboid. What is the lateral surface area? It is the area of four lateral faces. If you consider in general the top and bottom faces are considered as the base, then and the other remaining four faces are the lateral faces. So the area of the so the lateral surface area, which is denoted by LSA, is the area of four lateral faces, whose formula is 2 into L plus B into H. 2 into L plus B into H. Okay. Now, what is the perimeter of a cuboid? Perimeter of a cuboid is the sum of length of all 12 edges. There are 12 edges in a cuboid. If you take the sum of the length of all these 12 edges, that is the perimeter, and its formula is 4 into L plus B plus H. Sum of the length plus 4 times sum of the length plus sum of the length, breadth and height. Now, these form what is the diagonal? Diagonal of a cuboid is, if you consider any vertex, let's say if I consider any vertex A, it is the longest distance between any two vertices of a cuboid. Like AD is a diagonal. Likewise, AD is a diagonal. Likewise, BE is also a diagonal. So the longest distance between any two vertices in a cuboid is the diagonal, and its formula is square root of L square plus B square plus H square. And volume is the volume of the cuboid is that is the total space occupied by this cuboid is LBH, product of the length, breadth and height. Now these are the first 1, 2, 3, 4, 5. First 5 for these 5 formulas you must know very well. You must not forget, because these are the very fundamental properties or formulas related to surface area, perimeter, diagonal and volume of a cuboid. Okay. Now let us discuss a few other interesting things you must also keep in mind. Now, if you consider any three adjacent faces, in a cuboid, let their areas be any three areas of any three adjacent faces in a cuboid will be always LB, BH and LH. So LB, BH and LH are the areas of any three adjacent faces. So if I denote LB as X, if I denote BH as Y, and if I denote LH with Z, then there are some interesting results. Relation between XYZ and TSA. How can I relate XYZ? By XYZ are the areas of any three adjacent faces, and TSA is the total surface area. Okay. Now we know that TSA is equal to 2 into LB plus BH plus LH, and this is equal to 2 times X plus Y plus Z. So if you are given the areas of three adjacent faces XYZ, then you can find the total surface area as 2 times their addition, that is 2 times X plus Y plus Z. So from the area if you are given that the total area of three adjacent faces is some A, then the total surface area will be twice A. Or if you are given the individual areas of any three adjacent faces to be x, y, z, then the total surface area of the cuboid will be 2 into x plus y plus z. Now again there is a relation between the volume and x, y, z. Okay, now if you do the product of x, y, z, you will see it is x is LB multiplied by y is BH multiplied by LH. If you do the product, you will see it is L, B, H and whole square. This is equal to volume square. So XYZ is equal to V square, or you can say volume is equal to square root of X, Y, Z. So if you are given the individual areas of three adjacent faces of a cuboid, from that information also you can find the volume of the cuboid. So V will be equal to square root of x, y, z. Okay. Another very important and interesting results is how do you the relation between the total surface area, volume and diagonal. Okay. Now for that you must know this algebraic identity, that if A plus B plus C whole square is equal to A square plus B square plus C square plus 2 into AB plus BC plus CA. This algebraic identity you must know, or okay. Now applying this algebraic identity, I will apply this algebraic identity on the length, breadth and height of a cuboid. So I have L plus B plus H whole square is equal to L square plus B square plus H square plus twice LB plus BH plus LH. Now what is L square plus B square plus H square? You can see it is nothing but diagonal square, because diagonal we know D is equal to square root of L square plus B square plus H square. So L square plus B square plus H square is diagonal square. And what is 2 into LB plus BH plus LH? It is nothing but the total surface area, TSA. Now what is L plus B plus H? Perimeter I know, perimeter of a cuboid is 4 into L plus B plus H. So I can say L plus B plus H is equal to P by 4. So this is equal to P by 4 square is equal to D square plus TSA. If you simplify this, I will get P square is equal to 16 multiplied by D square plus TSA. So this is the relation. I am not asking you to remember this relation. No, you will never remember this relation, but at least try to remember this concept, this algebraic identity and formula, that is A plus B plus C whole square is equal to A square plus B square plus C square multiplied plus 2 into A plus B plus AB plus BC plus CA, and then you will apply this formula on the length, breadth and height of a cuboid. So I get P square, perimeter square is equal to 16 times the sum of D square, diagonal square plus the total surface area. Okay, I think these are all the important concepts, formulas and results for a cuboid. Now a cuboid in general, when it is said cuboid, it can be hollow or solid. Now specifically, if any problem, a problem will if required, a problem will specifically say whether it's a solid or hollow cuboid. All these formulas is applicable for both a hollow and a solid cuboid. Okay, now let's discuss cube. Now regarding cube, so these formulas, all the formulas of a cuboid you must know, remember very well. You should not forget all these formulas: LBH, diagonal, volume, perimeter, lateral surface area and surface area, and then that the area of if the area of any three adjacent faces are x, y, z, then total surface area will be equal to 2 into x plus y plus z, and also x, y, z will be equal to v square. These concepts and formulas you must also know. But this formula I do not expect you to remember, but you should be able to derive the relation between perimeter, diagonal, and the total surface area. Now let's see what a cube. Now what is a cube? Now cube can also be hollow and solid. A cube is basically a cuboid where the length, breadth, and height are all same. That is, the length of the breadth, breadth, and height are of equal value. That is, we often say that a cube. So a cube is mentioned by its edge length of a. A cube of edge length a means a cuboid of dimension a by a by a. That is, all the three dimensions, length, breadth, and height, all are same and is equal to a. That is meant by a cube of edge length a. Now for a cube, it is also sometimes called side length, edge length or side length. Okay. Now the formula for the perimeter, total surface area, lateral surface area, diagonal, volume for a cube you should not remember. This is my recommendation. You should not remember. From the formula of a cuboid, you should be able to find or derive the formula for a cube. A cube is a special case of cuboid where L, B, H are all same and they are equal to A. So you can see what will be the perimeter then of a cube. We know the perimeter of a cuboid is 4 into length plus breadth, length L plus B plus H. In this case, for a cube, L, B, and H are all A. So we have 12A. What will be the total surface area? It is based on the formula of total surface area of a cuboid. It will be 2 into LB plus BH plus LH. So we have 2 into A square plus A square plus A square, which is 6A square. Similarly, lateral surface area is 2 into L plus B into H. So we will have 4A square. And diagonal, it will be square root of A square plus A square plus A square, which is square root of 3 multiplied by A. So all these formulas, volume is A cube. All these formulas, it is not essential, not required for you to remember the exact formulas for cube. You should be able to derive them from the formulas of a cuboid. Now let's see some interesting results, relation between the volume, diagonal, TSA and LSA for cube. All these formulas that I will derive, the relation you should not remember, but you should be able to derive them. Okay. So let's see. I will start from the, let's say I am so volume is equal to A cube. Volume is equal to A cube. This implies that A is equal to cube root of V. A is equal to cube root of V. So from the volume you can find the side length or edge length of a cube. Okay. Now what will be the diagonal? Diagonal I know is square root of 3 into A. This will be square root of 3 multiplied by cube root of V. So I got the relation between D and V. Okay. Now what is perimeter? Perimeter is perimeter of is 12A. So once you A, the idea is 12A. Okay. So this is equal to 12 multiplied by cube root of V. Okay. Now how can I, so we got D is equal to cube root of 3 square root of 3 multiplied by cube root of V. So how can I express V in terms of D? From here, if I take cube of both the sides, I will get D cube. D cube will be equal to V multiplied by what is cube of cube root 3? It will be 3 cube root of 3. So this is equal to, or 3 into v cube root of 3. So this is the relation between so d cube or okay. So I am trying to derive what will be a v in terms of d. Okay. So this implies that v in terms of d will be d cube divided by 3 root 3. Now never keep root of anything in the denominator, always rationalize it. So if I multiply numerator and denominator with square root of 3, I get d cube by 3 multiplied by square root of 3. Now please do not try to remember this. Just you should be manipulating, doing some manipulation, squaring or cubing both sides. You can start from v, that v equals to a cube. A you will know. Once you know a in terms of v, then you can obviously find v or d or TSA or LSA in terms of any other formula or dimension. Okay, so v is equal to d cube by 3 multiplied by square root of 3. Okay. Okay. So I also got perimeter is equal to 12 multiplied by cube root of 3. So this is p in terms of v, but what will be v in terms of p? If I do cube, take cube, this will be p cube is equal to what is cube of 12? It will be a large number. Anyway, cube into v. So this implies okay, I think the better way is, okay, so v will be equal to p by 12 cube. So this is v in terms of p. Okay. TSA total surface area is 6a square. TSA is equal to 6a square. This can be what will be TSA in terms of p. P we know is A we know is p by 12, because p is 12a, a is p by 12. So this is 6 multiplied by p by 12 square, and this will be p square by, now I am not, please don't try to remember all these formulas. I am just explaining how you can create a relation between v, d, TSA and LSA. All will be based on a. You have to know v, d, TSA and LSA in terms of a, then you can easily make a relation between v, d, TSA and LSA. So this will be p square by I guess 24, if I am not wrong. Yes, 24. So this way you can make create relation between the volume, diagonal and total surface area and lateral surface area for a cube. Okay, so to mention or define a cube, we only need one dimension, that is the side length or edge length. Okay. Now some important things you must also concepts you must also know. If you consider a room is like a cuboid. Even though you can consider a room as a hollow cuboid. So what will be the area? It is often for many problems it is often required to find the area. So all the four walls of a room are the four lateral faces of the room, if you consider it as a cuboid. So what will be the area of four walls of a room of dimensions LBH? So if there is a room of length L, width or breadth B and height H, then what will be the total area that need to be painted? Obviously we will only paint the walls, so that area will be nothing but the area of the lateral surface area of the room, considering it as a cuboid, which will be 2 into L plus B multiplied by H. Now 2 into L plus B, now there is a mistake. 2 into L plus B is nothing but the perimeter of the floor. If you consider a room, then the L and B, 2 into L plus B is nothing but the perimeter of the floor. So you can also, so the area of 4 walls of a room is, you can consider it, the formula is 2 into L plus B multiplied by H when the length, breadth and height are all given. And if you are given only the height and the area of the floor, then also the area of 4 walls will be perimeter of the floor multiplied by the height, because 2 into L plus B is the perimeter of is the perimeter of the floor. Okay, the second point is, if you again consider a room of dimension LBH as a cuboid, then what will be the longest rod that can be placed or kept inside a room? It will be the length of the diagonal of the room, which is equal to square root of A square plus B square plus H square. So the diagonal of a cuboid, if you consider a cuboid as a room, then the length of the longest rod or any stick that can be kept inside the room is nothing but the length of the diagonal. The next is, when you will measure the perimeter or the volume or the lateral surface area or the total surface area of a cuboid or cube, then always consider the values of the length, breadth and height in the same unit. I mean, for example, if you are trying to find the volume of a cuboid or cube, not cube but for a cuboid, if you in doing the computation, if you consider the length to be in centimeter, the breadth to be in meter and height to be in meter, it will be wrong. You will get wrong results. Always first, if the dimensions, if the length, breadth and height of a cuboid are given in different units, always first convert them to the same unit, that is either centimeter, meter, feet, whatever, and then do the computation. Okay. The next point is that suppose a cuboid of dimension LBH is melted or reformed to form a cube of side length A. Then then what will be A? That is the side length of the cube. The idea is that the volume of the cuboid and the cube will be same. When a cuboid is reformed or reshaped or melt to another, let's say to another cuboid or cube, the idea is that the volume remains the same. The volume remains the same, not the total surface area or the lateral surface area. The volume remains the same. So so when a cuboid of dimension LBH is melted to form a cube of side length A, then we will have the volume of cuboid will be equal to volume of cube. Volume of cuboid is LBH, which is equal to the volume of the cube will be A cube if I consider the side length of the cube to be A. From here we can find A, which will be cube root of LBH. So these are some concepts and side results you must always keep in mind. I think that is all regarding the surface area and volume of cuboid and cube. Based on these concepts, I will be solving problems in the next 2 or 3 videos. So please stay tuned. If this video was beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I am ending the video here. Thanks for watching, and until the next video, take care and bye.